As you have seen in our advisor video earlier, chat memory advisors are going to help us to build a conversational style application, because using chat memory advisor, we can store our chats. So there are basically three kind of chat memory advisor. And in this video, we are going to see what is the difference between these memory advisor. First is message chat memory advisor. Then we do have prompt chat memory advisor. And then we do have the vector store chat memory advisor. And in this video, we are going to explore what are the difference between these chat memory advisors. First, we focus on the message chat memory advisor. When we are using the message chat memory advisor, our chat is going to be stored in memory, and this is going to be stored in the raw format whenever actually we are having a conversation with our applications. So our input is going to be stored under user, and then the response where we are going to come from assistant. And then if you are having this kind of conversation, then this is going to be stored in this format only in the chat memory. So this is going to be helpful where we need to preserve the exact structure of the conversation, and this allows the AI to reference a specific previous message directly, because the chats are going to be stored in the raw format. And as you can see in this particular diagram, memory is added as a sequence of user assistant message to the prompt. So this is going to be the message chat memory advisor. And as we have seen earlier in our code, if we have to access it, then we just have to invoke this new message chat memory advisor, and we just have to pass a chat memory over here. So the chat memory, we can create a bean, and then we can pass this chat memory under this new message chat memory advisor. This will help you to create a message chat memory advisor. After that, we do have prompt chat memory advisor. In this one, the conversation history is going to be merged with the system prompt text. So in this case, like if you are passing a system prompt, then you can probably just define a certain instruction how your AI application should behave. So when we are having the conversation, and if we are using the prompt chat memory advisor, then all those conversation are going to be merged in the system prompt. As you can see over here, history becomes part of the system instruction rather than the separate messages. And this is better for the cases where you want to provide a context in a more narrative form, and this could be more memory efficient as it consolidates the history. So this is how this is going to look like. Suppose we do have a system prompt like this, where we are saying, okay, you are helpful assistant, previous conversation context. Then the user asked about weather in Paris, and it was told it's sunny and 22-degree. Then they asked for a clothing recommendation for these weather condition. Please use this context to provide a relevant answer. So whatever conversation is, this is going to get merged in the system prompt. And on top of that, like if you are asking any particular question, like are there any good cafes nearby, then this is also going to be merged with the system prompt. So now you can see the user is now asking about cafes, presumably in Paris, based on their earlier context. Please use this context to provide relevant answer. So as soon as we are having the conversation, all those conversation are getting merged with the system prompt, and this is giving the context in the more narrative form rather than storing the raw structure of the conversation. And if you want to invoke this, then again, like you can just go to this code and you can just have the new prompt chat memory advisor. Under this, you can see like we can pass the string system text advice, and we can pass the chat memory. So let me just go into this first. If you're not passing, then there is a default system text advice which is getting passed over here. Use the conversation memory from the memory section to provide an accurate answer, and then what is there in the memory. And you also have to pass a chat memory over here. So whatever bean we have created for message chat memory, same bean we can pass over here as well. So this is going to take the chat memory, and this then we can use it in our application. And then the last what we have is vector store chat memory advisor. This is a more refined chat memory advisor. This is good for the application where you have to deal with large data set, because in this case it uses the semantic search to find a relevant previous conversations. Best for application with large conversation histories, can retrieve contextually relevant information even from older conversations. So the basic difference over here is it is going to provide the context based on the semantic search. So in this case, your text shouldn't be matching exactly, even if you are passing text in different words, but it is having similar semantic meaning, then it can retrieve the information from your conversation history based on the semantic search. You can also set up a window size to limit the amount of history retrieved. In this case, this is a more sophisticated one as we discussed, but this requires additional setup vector store, because here we are dealing with the large data set. We are talking about the semantic retrieval, then we need to store all this conversation in the vector store. So from the vector store, like it can take all this information and then add it up in the system text. As you can see on the Spring AI guide, this retrieves memory from a vector store and add it into the prompt's system text. And this advisor is useful for efficiently searching and retrieving relevant information from large data set. If you're dealing dealing with the large data set and building a production kind of application, then you should be considering Vector Store Chat Memory Advisor. We can get some idea from this particular example. So here you can have a previous conversation like last week, yesterday, and today. There could be some conversation about supervised learning, data processing. When we are asking some question, then it is going to convert it into a vector. Then it will try to find a semantically similar past conversations. Then it will pull the relevant parts about this supervised learning and pre-processing, because that's what we talked about earlier. And all this it will include in the context while providing you the response. Now, if you want to use it, then we have to just invoke Vector Store Chat Memory Advisor. And here, if you see in Vector Store Chat Memory Advisor, the first parameter, it's asking for the vector store. So it's not asking for the chat memory, it's asking for the vector store. So that vector store, actually you need to define it first. What you could do here, you could just pass a vector store, and this vector store that we can pass over here, and you need to define a bean of vector store so that like you can use it into this application where your chats are going to be stored. We have been defining a vector store earlier, so this is going to be our vector store, and here we have to pass the embedding model. So we can pass the embedding model and we can just pass it over here. So when you are going to define production ready application, then you actually have to use some production grade vector store. So this could be like MongoDB vector store, or could be like Postgres vector store. You can use all those vector store. It's just that like you have to define a bean first so that you can pass that vector store to your Vector Store Chat Memory Advisor. We just wanted to show how you can create a bean, how you can pass that vector store over here. So we are using this simple vector store. So that's the difference between all this vector store, and this is how actually we can initialize it and use it in our application. It is going to help you to build a conversational style chat application where it can refer your past chats and then give you the response accordingly. That's all what we have in this video. Thank you for watching.